Hey, how's it going? We're ready to go. We're gonna continue our Pytorch adventure, becoming Pytorch experts. Hey, hi, you joined in on there early before the stream even got started. Good to have you here. I don't know who are you? Is there a way that I can tell who you are? Wait, who's pressing those buttons? I won't let me see. If you don't chat, I can't tell. There's no way for me to know. All right, good to have you here. Good news is we got our model. It works. We got it working yesterday, and we saw that it was training. So what I need to do is, it does take a while to train because I only have a little teeny GPU over here. So we're going to start the training process. We're going to have the model get saved, and then we can start testing it. While the model is training, we're going to be writing the test phase. That's what we're going to do. We're going to go through the testing phase. That's the plan for today. I think we should be able to achieve that. That's a really easy goal. That's a really easy goal. We should be able to achieve that, no problem. All right, let's get going. Okay. We need to save the model. Let's see here. How do we do that? Custom data. Hey, Brother Saber, and welcome on in. Good to see ya. Happy Thursday already. I'm very excited for Friday and the weekend. Hope you are too. All right. I want to save the model. How do we do that? Okay, so we're going to use the same logic here. I'm going to retype it because I want to learn it. Hey, Developer Exotic, what's up? Good to see ya. We're going to be testing our AI model that we trained yesterday. In fact, we had to retrain it because we didn't save it. So we threw away all of the training. It got all thrown away. Hey, Torva, good to see you. Welcome on in. Hello to you as well. Good to have you here. We're going to be becoming Pytorch experts, you guys. Oh, how's it going there? Wait, what's your name? Shiva? Are we saying Idea Shiva? Good to see you. Thank you for saying hi. Welcome on in. Good to have you here. All right, let's keep on going. Let us get to the saving. Let's do a save. How do we want to write the model inside? Let's find out. Let's just do it. Let's just do it around here. Let's keep it easy and simple. So before we train the model, we're going to see if the model already exists on disk. And then we're going to load it, or we'll train it. That's the plan. Okay. So where is our model defined at? Right here. Okay, the model's defined here. What we maybe should do is put the code here. Okay, so model file is going to equal our Lynette.pth. And we're going to make it look good. Model files here. Right there. And then we're going to do a model load state. Is there a better way to load the model? I'm actually curious about this. Is there a better way to load the model? I do not know. Let's find out. Is there a more modern way? Because this way it feels a lot. It feels like there's a little bit extra there, right? All right, let's ask for help here. Why? Okay. Okay. Let's do an update. Rerun. Okay, so is there a newer load model approach? I'm actually kind of curious about this because we're going off of the tutorial, and the tutorial, it a little bit old at this point, and it has bugs in it. We found bugs, not just one, not two, quite a few, quite a few bugs. Okay. Oh, there's a torch.save. Check this out. Okay. If you want to resume training, the newer practice pattern is to save the full checkpoint dictionary, not just the model weights. Torch.save on our model state and the optimize. Oh, okay. So we could use torch.save. Am I already using torch.save? Let's find out here. We are. So I'm already using torch.save. Safe tensors. Torva, what's that? What are safe tensors? Oh, it's a new file format. Got it. I know what you're talking. It's not new. That's been around for a long time. I've seen that one before. We should probably use safe tensors, is what you're saying? Okay, let's use safe tensors. Let's do that. Okay, how do we do that? How about safe tensors? All right, we're gonna find out how to do that real quick. Yeah, we could load .pth file that way, even with safe tensors. I'm checking the current source on safe tensor guidance. Okay, let's see what we have here. Device CPU. Okay. I want to do this on the safe tensors. I'm going to try. If you want, you can rewrite your snippet into a version that tries safe tensors first. Hold on. Okay. Safe tensors. Oh, Okay, it's a whole other library. All right, 1 second. Let me read this. Okay, so how do we save? State dictionary. Train. Okay. So we could check. All right, we're going to do the Torva. Since you said to do it, we're going to do it. We're going to do it. Okay. By requirements. I guess we don't have a requirements text file. We don't have a requirements text file. Hold on. Requirements.txt. We don't have this. All right. Safe tensors. Is it safe tensors? It saves the weights. Just the weights. Not the gradients and not any of the other things. Just the weights. The biases and the weights. The weights and biases. Okay. So we're going to import safe tensor. Safe tensor. Let me copy paste that real quick. Let's double check that I got that right. Looks good. Okay. Safe tensors. Torch. Vision. Numpy. Was there something else that we used? What else do we use? We use matplotlib as well. Yeah. Okay. So matplotlib. Let's grab this real quick. Matplotlib. Pandas. We use pandas for the CSV, although in this case, I usually want to stay away from pandas. Hey, theoretically physics, how's it going? Physicist. Oh, wait, hold on. Physicist and polymath. Hello, futurist. Hello, good to see you. Welcome on in. We are doing future stuff here. This is the work of the future. We are going to become Pytorch experts, you guys. That's the plan. All right, we got Torch Vision, Torch Utils, Torch Pandas, Matplotlib, Torch, and Sys. Awesome. Okay, all good to go. And now we're going to have a new one called from safe tensors import save. What was it called? Save something? Save file. It's called save file. Underscore file and load file. Comma load file. There we go. We're going to use this approach. Oh, wait. Ooh, whoa, wait. Hold on. Okay, we're going to do this. All right, we don't need that here. There we go. Let's close that. Okay. So we're going to do save file and load file. Hey, Mohammed, good to see you. Welcome on. Hi, good to have you here. Happy Thursday. We are building ourselves a convolutional neural network. We got it working. We had it trained yesterday successfully. It learned. We found that it learned. Now, what we're going to do is we're going to save and load the model. So that way we can start training in the background because it's going to take a while to train. It takes a smidge to train because it's a lot of data. Are there any free finance APIs to use? Oh, hey, Mohammed, that might be are there finance APIs that you can use for free? What are there? I use Y Finance. Have you heard of Y Finance? Most of them are costly. How about Y Finance equals free? It's free. It's so free. Y Finance. It's on Python and JavaScript if you want it on JavaScript as well. So just go pip install Y Finance. Write this. Close that. All right. Pip install -r requirements. Make sure we got that. All right. Good to go. All right. Pip install Y Finance. Boom. Like that. There you go. Get that dependency chain going. Y Finance. There you go. Well, a smidgen, quite more than I was expecting it to download there. Hey, thank you for the hearts. Appreciate it. Is that a library? Yeah, it is. It's a library. It's got books in it. And, well, does it have books, though? Or just files? It's got files. It's a library of files, you guys. Thank you for the hearts. Appreciate it. Good to have you here. Okay, I think we got everything we need. We installed all our libraries. We're going to do safe tensors now because Torva said use safe tensors. So we're going to do that. And we're going to do that here. Where's our model file at? All right, we're here. All right, so we'll go. Let's bring our codex back real quick because we had this is the we'll do the same thing except with load file and save file. Okay, model file looks like good. Okay, model file exists. Let's see, where's model file? Oh, it's a path. I want to use the other one that I was doing before, where we're just using OS. Do we have OS? Import OS. We'll do it like that. So we're gonna do it differently. Here we go. Custom data, operating system. Right here. That's what we're gonna use. Okay, let's type this out. We're not gonna copy paste. We're gonna type it out because it's gonna help you memorize and get better. Let's get better together, you guys. Let's do it. Okay. So if operating system.path exists, and we say model file. No, not momentum, model. Model file. There we go. Then we're going to load the model, which is going to be a little different. We need to load we're going to do it this way. So state dict and load. Oh, there we go. Okay, so we're going to load the state dictionary first. Okay. So we'll go state dictionary equals load, and it's going to be the model file like that, I believe, right? We get that part right? I think so. Little easy one. Easy. Oh, device CPU. Do we have to say device? We're just going to say default. We'll just leave it at default. Hey, I want to build a GPT. What do you think? Build a generative pre-trained transformer. You want to do that? Train a vanilla transformer from scratch with Wikipedia on some book data. Yeah, that sounds great. There's a mini GPT. You can do mini GPT. It's a really good starting point. You be warned, though, it is a very expensive, time-consuming, resource-heavy operation. And it takes a while. I did this on a GPU. What you're doing right now, I did this on a GPU, on an NVIDIA GPU in the cloud, and it took 24 hours. Eventually, it started working. Eventually, it had coherent data. Eventually, it took 24 hours, though. So if you have a GPU and you're ready to go, you're ready. You're ready at that point. My name is Mohammed. All right, Mohammed, good to have you here. Also wanted to dominate this field, but it seems like a nightmare. Well, there's a lot of complexity to it. There sure is. Good news is we're going to learn to become the experts together. We're on the journey. Let's do it. The big part is mostly memorization, understanding each of the components. You don't have to really do that part. You just have to sort of memorize it and know which parts works under which conditions. That's it. It sounds like a lot. I know. The good news is the understanding comes eventually. It will. All right. So we're get our state file and we're going to go model.load. Was it load state dictionary? Yeah, load state dictionary. State dictionary. We've got our state dictionary here. Like that. Is that what we want? Yeah, let's do that. Okay. Let's make sure this works. And this is going to be called safe tensor. Oh, there you go. Really big file extension. I don't know if you ever have used a safe tensor like that before. Safe tensor. All right. That's just going to be the weights and biases right there. Weights and biases. Else, we're going to train the model and then save it. Do we need an else? What do we want to do? Else for, else we want to train the model and save it. Okay. So this is where we could do the else at. How can we connect mail? /studio, how's it going over there? Mail, you want to do Discord, /studio, Discord, mail? What do you mean mail? There's Discord these days. All right, here we go. I'll send you over to the Discord link at /studios. There's the Discord link for you right there. And then send me a direct message. You'll find me, click on my face, right? You'll click on my face and then send me a direct message. I'm around here somewhere. General chat. Am I in here somewhere? I'm usually under a link shared. I usually share links. There we go. So yeah, see my face, click on that, and then you go direct message here. You're good to go. Discord link is in Steven's link profile. That's also the case. Yeah, Torva, thank you. All right, so we have to do training. Train here. Let me think about how we want to do that. And then we want to save the dictionary. So let's do this. Save. And we're going to do... How do we do this? Let's find out. Oh, we just do state. Oh, and the model file. Okay, save file. Okay, so this will be model.state dictionary. Is it a function? Yes, function, comma, model file. There we go. Right there. All right. Easy, easy. Great. So we need to move the training logic there. How do we do this in our other one here? I'm curious about that. Save. Where's that at? Here we go. So train. Okay. So what we did was we put the epoch calculator here, which I like that approach. So let's do that. Let's do the same thing because it's clean. It's really clean. So I'm going to delete this and call this def train like that. And then we're going to put the train logic here like this. train epoch. There we go. As thus we do. Lynette.epochs. Yes, there we go. I think we did it now. All right, good. Okay, let me double check. Train epoch. Okay, epoch. Just like that. Is that good? Yep, I think we're good. We're good to go. Hi, I watched your stream yesterday and have a question. All right, Spudnik. Spudnik means what's your question? How do you learn coding? All right, good question. We gotcha. You start typing in a text editor like we're doing right now. Type in the text editor the code that you want. And the good news is you don't have to understand it. In fact, don't try to understand it. Just kind of follow along in tutorials and try to build things. Then go into a goal of building an app. Make an app, and you'll have to learn how to build at each stage. And you have to go to the internet, go to the AI and say, how do I make this happen? And you start typing it in step by step. Eventually, things will start making sense. It takes a while. It's not instantaneous. It takes a smidge. You'll get it though. It'll come, it'll happen. Eventually things start clicking. Things fall into order. Because you're building up all these like memories and towers and things like this. Build. And eventually things start connecting. Thank you. Yeah, it's my favorite way. Although, definitely ask the AIs, because when I was doing this, the AIs weren't around. There were no AIs to help me. The AIs will help you. Don't rely too heavily on them though to fix something that's broken. Try to fix it yourself, because you're going to run into problems, and that is the necessary foundation for memorizing. If you don't have that, you only learn from the AI with what works successfully. And what you miss out on is 99% of the knowledge of what doesn't work. That is the key. Now you got it. You want that 99% of the knowledge, which is foundational of what doesn't work, because you tried it and it failed. You need that knowledge. You gotta have it. I'm motivated. There you go. Yeah. All right. Hearing good. That's great to hear. What are you making? We are building a convolutional neural network, which is going to be a computer vision model that identifies pictures. We built the model this week so far. We're going to train the model today. We're going to run the training. We're going to save the data to disk, so we have the model file on disk. And then we are going to test the model with our test training set to see how accurate it is. Did it learn anything? I don't know. Can it guess accurately on data that it's never seen before? That's the whole point of AI. When you have AI, you train it on a whole bunch of data, and then you present it new data that it's never seen before. And it's supposed to be able to accurately predict whatever outcomes you're looking for. Identification of objects, for example, in a picture. What's that? What's this over here? What's that? A human can do that. And now we've got AI that does that for us. There we go. Automation, you guys. Taking over the world. Let's make it happen. All right, so we've got our lost item. We're doing batch 64. All right, we can increase our batch. We don't need that. We're not doing cost anymore. We're doing losses. Do we have a cost over here? Are we still using cost? Nope, we're doing losses now. We're doing losses now, which is also the cost. Let's do cost. Cost. We'll do this. Let's change this to cost. And then our cost. Losses. Do we still have that anywhere? No, we're good to go. Hey, Peace47474. Good to have you here. Thank you for saying hello. Welcome on in. Happy Thursday. All right, another number of batches. Okay. This is save losses for tracking progress of model. I'd also like to add a percentage. Hey, how's it going there, Adam? Mister, good to see ya. Hey, welcome on in. All right, good to have you here. Hey, how's it going there, Loons? Hey, Loons, good to see ya. You're over here on the YouTubes. You're on YouTubes now. How long have you been learning Pytorch? On and off for a few years. I've only started really deeply learning it this month, because I've done AI before. For many years, I've done AI. Before there were frameworks, I started working on AI. Before the frameworks even came out, I was starting AI. Built my own frameworks, built my own neural networks. Now that frameworks have all that math built into them, So let's learn the frameworks together. Going to Twitch like in 40 minutes. All right, sounds good, Loons. We'll see you there. When you make it on over, I'm already over there. Hey, man, you're so goated. Hey, Mr. Adam. Well, thank you. We've been doing this for a while. Just a few decades. Just a few decades. Over 25 years professionally, which means that I've been making money with it professionally. Actually, probably longer than that. Because I'm only counting like when I really got into it full time rather than part time. Kind of feels like abstract English for me. When you look at code, you kind of understand code from what it's saying, like the industry standards logic. The rest is mostly just weird. Yes, punctuation in a way. GOAT, greatest of all time. Thank you, Mr. Adam. You got it. The way Torva describes it, that's exactly what it's like. Okay, so we got a lost item, a cost depend, looking good. I want to test this out really quick. All right, training. Okay. La. What's R? What are we using R for? Oh, we're not using R at all for anything. But I will move this over here as a reference for later. Here we go, like that. Just like that. We don't need R anymore. R is not being used for anything. Okay, here we go. How do you even read code with the heck? What the heck am I looking at? Oh, Dino, how's it going, Dino? Well, I typed all of this, so I kind of should be able to read it. I typed it all. Bro, can you give me an advice if I want to make an AI startup? Sure, absolutely, Adam. Send a DM on the Discord. Sometimes when you try to understand something complex, I try to relate it to code, and then you understand it better. Loons, I don't think I've ever done that before. Loons, you might be onto something there. That's a good idea. Okay, so there's some advanced complex concept that you've been presented with. You've never seen it before. Uh-oh, danger zone. How do you take time to understand it? Well, if you type it out in your head as code, you might be able to understand it more deeply. That's a good idea. I never thought of that. Thank you. Hey, K-Man. All right, Mr. Adam. Thank you. Adam, Mister. Appreciate it. I'm Lorix, if you remember. Lorix, hey, Ketty, Lorix. Yes, absolutely. It's been a while. Good to see ya. Welcome back. Good to have you here. I want to run this now and see if it's gonna look all happy and pretty. Let's make sure it looks good. Uh-oh, we got a problem. Save file. Can I import save file from safe tensors? Why not? Save file. Save file. It's save file right there. I've never done safe tensors before. Hey, Mr. Dungwall, good to see you. The same principle of thinking complex solution in another language. Oh, if you can do that, it becomes less complex. Instead of human language, you're using code. Hey, that's a smart idea. If you're, think of it in a different language. Same thing works with code. Why can't I import save file? Import save file. I want to. Am I doing this wrong? Oh, .torch. Okay, I missed something. Here we go. Let's go back. La. Going back over here. Torch, safe tensors, .torch. T-O-R-C-H. There we go. Man, can you change the song? It looks like you're making a model to hack the... Oh, I know, right? All right, here. It did get serious for a second. It's on Final Boss. This is called Final Boss. How about that? Okay, we're in Happy Land now. We're back in Happy Land. There you go. All right, safe tensors. Yay! Good call, Adam. Good call. All right, so now it should work. There we go. Enter. Here we go. Success! Don't worry about that warning. I really want to get rid of that warning. Oh, wait! Oh, I know why. Okay. Don't worry. We'll fix it. 1 second. Here, I'm going to do this. Train the model. This is the optimization phase. There you go. Boop. Okay. Like this. Okay. Wait. Whoa. Time out. Are we missing anything? Yes, we are. Okay. Let us do a few things first. Let's bring these things up higher. Like this. Like that. This is the essentially main. Oh, and then Wait, there's some other things over here. Okay. Like that. All right, perfect. Okay, like that. All right, I believe this is it. This is it right here. All right, we should be good to go now. We should be good to go. It's actually all correlation study, as most of the highest IQ people in the world ever speak more than 3 languages. Oh, really? Something like that? Oh, really? Oh, okay. So you can be, it's really smart. All you gotta do is speak multiple languages and think in multiple languages, and you increase your intelligence. It's a little late to ask, what is the tensor? Okay, a tensor is a number. It's a number or a set of numbers. Are you ready? All right, Python, watch this. Are you ready, loons? All right, so import torch, torch.tensor. When you put an array, it's like a bunch of numbers together. There's a tensor right there. It's just an array. You can also do a tensor as a single number, like that. It's a tensor. Essentially, it's a framework that works around a series of tensors, a series of numbers or groups of numbers. And you're able to apply math operations to the sets of numbers, right? So you can have 1 equals tensor.1, like this. La, 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 la. And then you can have array, like this. La, la, la. Array equals. And you can say 1 plus array. And it gives you output. So you can do these math operations. So it's a nice way to do math operations on sets of numbers. Isn't that cool? Print hello. All right, we'll do it. Print hello. There you go. All right, almost got it. There you go. Printed hello. Gotcha. Hey man, how you doing? I moved, so I wasn't here last stream. Oh, Heartwired. Oh, congratulations on the move. I hope it's a good move. Never too late, brother. Never too late. I know, right? You can always learn a new language. Hope. Hey, we're doing well. We're doing well, Heartwired. We are doing well. Thank you for asking. Dude, help me stop your Sophos. Oh, inside out coconut. Yeah, the endpoint Sopho client from deleting your kingdom come deliverance files. Why are you running Sophos on a gaming computer? To verify that it can't figure out what they are. Whitelisting does not work. Oh man, you just don't run Sophos on your gaming. Your endpoints. Okay, so Sophos endpoints isn't that just the networking layer? It's not disk stuff, is it? Sophos has multiple scanning capabilities, right? It's got a local scanner. It's got a registry for SHAs on binaries and other signatures for malware detection. It does quite a few things. Inside out, so you might want to change the save file directory, I don't know, and then have that save file directory mount over to a backup system, and then you can always have your files saved there. Or if you have full control over Sophos, just tell Sophos not to deal with that directory. Look for the save directory and say, Sophos, nah, that's it. Don't touch that directory. Stop touching that directory. Thank you for the hearts, you guys. Loons is kind of like a weight on a giant scale. The results in AI gets interpretation of the results, tilt of the scale. The scale tilting of the results. It's a good way to put it. That's a good way to say it. So that's a tensor. That's a tensor for you. I hope that made sense. If it didn't, then it's just a bunch of numbers. That's all I could say. It's just a bunch of numbers or one number. Did you see the Unsloth Studio release? I did not, Heartwired. What's that? We could go look it up. You're right. We could go look it up. I want you to tell me about it. Heartwired, you should tell me about it. Tell us about it. Okay, so this will... Do we already have that here? Okay, main. Okay, load. Good. Looks good. Okay. This should run without crashing now. Is what we said every single time, and then eventually... darn it. Okay, batch. Okay, so that's no problem. That's not a problem. Where is that at? Line 165. Cannot locate variable batch. Yeah, we put the batch right there. It's right here. It's right here. Oh. 1 second. No. That's fine. Let's move this here. No, we can do that. So it's right here. Train. It's right here. Why is it not working? Unlocal bound. Yeah, batch. Okay, so batch right there. Oh, cannot access local variable batch. Oh, okay. No worries. Another day, another Blum. Hey, special live stream, Catholics. Welcome on in. Good to have you here. Unsloth is an optimization for large language models. Oh, is it? Okay. The release of the open source studio for fine tuning and inference MLX should come this week, they said. Hey. Okay. Okay. We're getting new technology, Heartwired. Appreciate it. Thank you for the mention. We do use quite a few of those things these days, don't we? Those LLMs on a regular basis. Are we using them right now? This very second? How many Claude sessions do you have open? Do you use open, what is it? Do you use open source versions models with the open source version of Claude? I think your last message got blocked. Oh, did it, Mr. Dungwall? Yes, it can get blocked. If you're, let me see here. Yeah. Yep, your last message got blocked. Sometimes that happens sometimes. YouTube is very, very generous with that. They're very good though. Last message got, have you seen glitchy website that shows GitHub dev profiles as cities and buildings? It's crazy. 103 viewers. Whoa, hey everyone, good to have you here. It's a new record, everyone. We're gonna be learning Pytorch, you guys. We're becoming Pytorch experts. Join me, become Pytorch experts, you guys. They got good AI resources. Nice. Yeah, was using open code in GLM 5. Oh, nice. Open code, nice. Very nice. Okay, so let's load and train our model, you guys. Let's do this. I have a problem though, right here. Let's see, do we go batch equals 0? You know what? We can do this here. We can do this here, like this. Watch this. Boom. Well, no, see, that's the problem though. That's a problem. Hold on. This isn't gonna work. This isn't gonna work. We need to do something different. All right, I need to think it's a convolutional neural network. You got it. A CNN. Thinking about writing your own harness in Rust. Oh, very nice. Y'all, I'm new here. We're building an AI model. You got it, Matchstick. Yes, we are building a convolutional neural network. We've actually written this already this week. We're very successful. We got it working. We're just rearranging things now in this file so that we can start training process. Once we start the training, it's going to take a little while because there's a lot of data. Live on stream, we're going to make sure to train this, and we're going to save the data on the output, and then we're going to load the model and start testing it on test data. That means that we're testing it on data that it's never seen before. That's the whole point of AI. You give it a whole bunch of data. It's like, here you go, here's a bunch of data right there. Here's a bunch of data. Learn that data. Okay. Now that you've seen that data, here's a whole bunch of other data that you've never seen before. Can you make sense of that data referencing your old data learnings? And that's AI. That's what AI is, you guys. That's what AI is. Good to have you here. All right, let's make this happen. So I am not, well, I suppose we could do that. We just need costs maybe to go here. I suppose we could do costs like that. Let's try this. Let's see if that works now. Let's see if that works. I'm pretty sure it'll work. Hey, bro, did you hear about Keep Android Open? Hey, there it goes. It's working now. All right. Perfect. Okay, so while that's training, hold on. Before we let it go for too long, read your comments. Hey, I was going there. Hey, bro, did you hear about Keep Android Open? What is that? I don't know what that is. Tell me about it. I heard Markov got a new chain. Did it? So we got some new chains in Markov. Just Combat 4. Welcome on in. Good to have you here. Tell us about Keep Android Open. I'm actually kind of curious about that. Also, y'all's chats sometimes don't show up because they get automatically removed by YouTube. It depends on the situation. Got good AI resources though. Okay. All right. Good to have you here. What system are you using? This is a Darwin system. So we are doing uname dash, here we go, Darwin. And who knows what Darwin is? Who knows what Darwin is, you guys? I'm wondering how many of you know what Darwin is? All right, Darwin. How is it not viral, my guy? Is building model from scratch? That's what we're doing, pretty much. Although we're using a framework, so we've built models from scratch, completely from scratch, live on stream several times. I'm curious, y'all, if this is interesting to you. All right, what is Darwin? Linux? Is it Unix? Unix, maybe, or is it Mac? All right, let's see what you guys come up with. Okay, so before that gets Thank you so much. Just checked your channels. Pytorch tutorial. Hey, study. We're doing it. Pytorch tutorial. Matchstick, you got it. A Linux distro. Could be a Linux distro. Let's see. The initiative are... These changes restrict users' freedom. Oh, third-party apps like the F-Droid. Oh, and turn Android into a closed system for similar... Oh, no, we don't want that. Unix, hey, bro, new subscriber. All right, Saga. Good to have you here. If I'm saying your name right, let me know. Saga, appreciate it. Good to have you here. All right, so let me pull this over 1 second. I'm going to drop the epochs before... I'm going to drop it to 1 epoch. Because I want to make sure that it's going to save and load before we train it too hard, and then we're going to start the testing process. Saga, all right, good to hear it. Let's see, let's make sure this works. Okay. Hey guys. Hey Edits, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. We're learning Pytorch today and all this week and next week. More Pytorch, you guys. Hey friends. Good to have you here. Aren't the kernel levels similar for all Unix, Linux, Mac? Yeah, kind of. A little bit. Hey, SQ Lighter, good to see you. Welcome back on. Good to have you here. That's Neva's sibling, you guys. Hey, Kyle. Woo, thank you for the super chat. Appreciate it, $2. Hey, all right, Kyle. You're always very generous with these things. Kyle, that's so great. All right, how do we say that? Let's see here real quick. Thank you, exclamation point, party popper. Let's do some party poppers there. Thank you, Kyle. Appreciate it. Guys, it's 1 a.m. 1 a.m. It's sleep and time to check this out tomorrow. All right, Matchstick, thank you for joining in. Good to have you here. All right, see, I knew this is why we did this, you guys. This is why we did this. So, hey, Nathaniel. Hey, Nathaniel, good to see you. Welcome back. Good to have you back. All right, so this is why we did this. This is why we did this, you guys. Again, Kyle, thank you. Appreciate it. Oh, my gratitudes to you. I was not expecting. I always the anticipation. All right, where is it? Model dot. There we go. Where are we at here? Around here. There we go. All right, it's not called model. It's called Lynette. All right, Lynette. There we go. Wait. Yeah, perfect. Lynette. And that's where it failed, right there. See, that's why we did this. Hello, Kyle. Yeah. For more info, please. Hey, Just for Combat. All right, did you say some other thing, Just for Combat? Yeah, okay, got it. Yeah, Android, more info. The movement web devs must participate. Got it. Okay, so we want to keep Android open. We sure do. You're right. Android should stay open. That's why I use Android. I like my Android, you guys. I'm an Android user. We got to keep our Androids here together. Got to keep the Androids. So are the kernels similar? Linux, Unix, Mac? Are they similar? In a way, they're similar. Yes, they are different. They are different, you guys. All right. Hey, Pierce Trophy. Torpy. Hey, Pierce Torpy. Good to see you. Thank you for saying hi. What are we doing here? All right. We are... Oh, perfect. Did we do the safe tensor? Yes, perfect. That's what I was looking for right there. All right. We got the safe tensors right there. The safe tensors are good to go. So now I need to delete that file. RM Lynette. Wait, before... Wait. Let's try to load it. Let's load it. It should be bump instant. Boop instant. Nice. All right. Got it. All right. RM Lynette safe tensor. Okay, there we go. Success, you guys. There we go. Success. That's what I'm looking for. Good to have you here. Search it on Chrome and make the video to spread awareness among the developers. Yeah, all right. We will look into it. We'll look into it. Actually, it's just a kernel. Linux is actually just a kernel. You know it. It's the way to run it. Not the same as Mac. Mac is closed source. It's not the same. You know, exactly. It's a closed source system. All right, you guys, let's make this happen. So what we're going to do is we're going to train this model in the background. Probably let's do 15 epochs. Let's do 15 epochs. Begin the training process right here. And now we're going to start writing the code to test our data, to test our model. How's your day been? Yeah, we're doing good over here. Oh, Kyle. Oh, you're talking to Kyle. All right, you guys. It's running, it's learning. So now, while it's learning, we're going to update our code. We're going to jump back to the tutorial, and we're going to start working on the test part. So this will be def test right here. Perfect. Okay. So let's go over here. All right. So continue on forward. So we did all of our losses. Yep, that looks right. That looks like the numbers we're getting. Let's do the testing phase. Where is that? Torch. Okay, so here's the testing phase, I believe, right? Torch max outputs data ops nat. Okay. Torch max outputs data. Okay, the max. Do you want the max or the argmax? We're doing something different. Okay. We cannot use this because it is not the same. We'll have to change it up because we're doing it different, you guys. Learning as an AI. Yes, exactly. We actually are learning an AI framework called Pytorch. And we're training the AI, so the AI is also learning right now. This very moment. Not a little bit, all the way. Right there, you guys. It's learning right now, this very second. Okay. All right, good to have you here. So we are going to do a no grad on the test loader. Images and data. Okay, good. All right, let's do this. This is the testing phase right here. That's all we need. That's all we need right here. So we can write this out while our model is training. So we're only on the third epoch of 15. So we got time. Me and Neva are working on something in CMake. Okay, so compile system or compiler orchestration system is CMake, right? We just can't figure out a single problem. It's been like 2 hours. Oh, what's the problem? If you tell it to me, I probably won't be able to help you. However, your explanation might help you along the way. Usually rubber ducking helps a lot. Rubber ducking, you guys. It's called speaking to a toy duck and saying, hey, I've got a problem. Right now, my tensor's not saving. Why are they not saving the disks? What's going on? Why is there a problem? You describe your problem to the rubber duck. Like you're holding the rubber, it's like you're speaking to a rubber duck. That's how that works. All right, let's build the test, you guys. Let's build it. So we've got our test data. So our test data is in Lynette. Whoa. I'm actually kind of curious. Yes, that should be fine because where's our test data get loaded at? We could do a load test data right there. Oh, it already happens on initialization. Okay. So that should be fine. So we should have all our test data there. Perfect. Okay. So let's do our test. Lynette.no grad. I think we can do that. There's also inference mode at torch.inference mode like this. I think we can do that right there. I think we can do that. I'm pretty sure. So we don't need to say no grad. We can just say inference mode. There's something called geode. Instead of using an already made CMake, it decides to make itself. What? Hold on. What? And then a problem occurred. It seems like a problem to me. What's the error message? Okay, you guys, let's get going. All right, so let's load in our test data. Our test data is up here somewhere. Where's that at? Here we go. Test data loader is right here. Okay. This will be called Lynette.testloader for data in. Okay. And then we'll say our could we instead do images, comma labels like that? Can we just short circuited it? Can we make it a little bit easier? Rather than having it on 2 lines, you have it on 1 line. It's a little bit cleaner. Can you do that? Is that possible? We're going to find out. We'll try that. Okay. Then we're going to grab our output. This is the output, the answer, right? We'll call it answer though. Answer equals Lynette images. Like that. Okay. And our test loader has a batch size of 4. That's fine. Okay. Okay. You don't have a clue? Only Neva knows? Oh, how to use commands to currently... It's full of garbage. That usually happens. I've been in that situation before. Especially in the early days of Rust. Have you guys tried to use Rust like 10 years ago? You remember what that was like? Using Rust 10 years ago? The compiler was trying to be helpful, and it was not. It wasn't at all helpful. It's a lot better now. Okay, so we got our answer. And then we are going to do something different. We're going to do argmax. So how do we grab this? Where's our argmax at? I think we'll be able to figure this out. All right, so our torch.argmax, and then we answers axis equals 1. Something like that. Let's see our you know, how about this output? We'll put the output here and we'll say answers like this. And then we can start comparing the actual labels. So print answers and print our outputs. Print. We'll try just to double check output, and I'll print our labels as well. All right, like this. We've got time though, so let me double check. We've only got 4 epochs to go. Okay, good news. Okay. I've actually been learning C. Nice, Adam Mister, great. Same as Rust on a low level. Only problem is on memory management and safety. Yeah, you got it. Hey, Nathan Mycroft, what's up? Good to see you. Welcome on in. Happy Thursday. Good to have you here. All right, this is going to be the answers. Colon. We could use an F string. However, these are tensors, and I want the full raw tensor data coming from this. And instead of printing it like that, I'm gonna do a little bit different. We're gonna go like this. We're gonna have some nice outputs like this. We're gonna bring this up here, and we're going to have our labels. If that makes sense. I think it might. Okay. This will give us all the information that we need based on how accurate the model is. So all we have to do is wait for the model to train here. We've got 2 more epochs to go. Well, 3, right? 13, 14, and 15. So we've got 3 more epochs. We're almost there. And it will give us our training data on our weights, and it should save it to a file called, what is that called? Linnet.safetensors. Because thank you, Torva, for our safe tensors. We're going to use safe tensors. Why are they safe? Why are safe tensors safe? What does that mean they're safe? Let's consult the internet. Okay. All right. Why are they safe? Safe tensors. Why are they safe, you guys? Do you know? Warning. More than 2 or more files with the name of some O-rate stars layer.c++ will produce the outputs in the same location. This can lead to an incorrect build result. So is that the O file? There's too many O files. The O files reference each other. They'll overwrite each other, so you build one file and it's got the same. You don't know? Okay. Once you build, so you build object files, right? Each object file has a dedicated, from each C++ file, there's an object file. I'm pretty sure it's basically the same as C. It's been a while. Okay, let's read this. They're called safe because the format is designed to store tensor data only, without relying on Pytorch pickle, which can execute arbitrary code during loading. Oh, well, we kind of want that, though. Pickled-based model files can be dangerous if they come from untrusted sources. Oh, now we know. Okay, safe tensor means it's just the data and none of the risk. For the most part, right? No, for the most part. I think it's just called that because they're saved and nothing else other than the tensors. Got it. Yeah, so it would be great. Hey, you're back on Twitch. All right, Loons. Good to see you over there on Twitch. Now make a mod for some video game and it's object in-game. And it's an object in-game. It's streaming. How's it going there, Champer? Good to have you here, Champer. Is it streaming? What do you mean? We're streaming right now. Oh, good. It finished. Okay, do we have the file? Yes, look at that. All right, so we've got our safe tensor. We're good to go. Let's start testing it now. Okay. Let us try it. So we should be able to start testing this here. So let's see if it works. Do we do model 2? If we're loading the model, should the model, can we do model Linnet.to device like that, and then .to device, because we want hardware acceleration, because it's going to take a smidge. Return So we only get one. We only need one batch. All right, let's see if it works. Oh, why the subtitles respond so fast? Oh, it's my technology. Ah, I got it. I see what you're saying. So yeah, I wrote this technology 8 years ago. So you can see there, 8 years ago. Hey, how's it going there, Kevin? Kevin, thank you for subscribing. Appreciate it. Welcome on in. Happy you joined. This is the right channel for software engineering. If you're interested in learning and becoming a Pytorch expert, that's what we're doing now. 8 years ago, exactly, Loons. It allows you to add real-time live subtitles, which are called open captions. They're called open captions because you cannot turn them off. I have control. Only I can turn them off. Hey, Kevin. Hi, Steven. Good to have you here. Thanks for subscribing. Welcome on in. And so you can, it's open source. It's completely open source. It's free. You can use it. You can use it all you want. It works on Zoom, works on Microsoft's Meetings, which is Teams. It works on Google Meet, Google Video, right? Google, and other things. Hey, buddy, sure. Nice. Appreciate it. All right. So yeah, it's right here. If you want, I'll put the link over on our Discord under the link share. And there you go. Link share on the Discord. Live subtitles. Okay, so let's keep going, you guys. What did you use 8 years ago as speech to text? Speech to text is called Spoken. The Spoken library. Spoken.npm. Here you go. Right here, Spoken NPM. Text to speech and speech to text. Artificial intelligence for chatbots. And then I just repurposed it so it works right here, live on stream. Hey, Ghost, good to see you. What are we doing? We are building a convolutional neural network in Pytorch. We are becoming Pytorch experts following every single tutorial available to us. We're building a model that does computer vision. Obviously, that's what you do with the CNN. It's meant for two-dimensional or multi-dimensional data, where you can take meaning between relationships between pixels as they are near to each other. So that's what that convolutional part is. It's going to derive meaning about the neighboring pixels and their relationships. So if it's a 3D image, you can have like a little cube. If it's a 2D image, right? Usual photographs are 2D images. You can test the pixels around each other, and then you can start processing like things like circles or half circles. Oh, and then, oh, that's actually an eye, or now that's a person's face, right? That's what it is. And you made your own library? That's crazy work. Yeah, I know, right, Loons? A long time ago. Oh, gonna continue tomorrow when Neva? All right, sounds good. Have the attention to actually, because you don't know what you're doing right now. I know, it can get overwhelming. It can. So, let's see if it works. Is it gonna work? Is our test data gonna work? Is it gonna load? Okay, it's loading the data. Oh, wait. Oh, did we not run? We didn't even run the test function. Okay. So load, Lynette, and then we'll go test like that. So this is, wait, I suppose we could test it either way. It's gonna be testing either way, right? So let's pull this here. Test, like that, okay. Now we're gonna get it, Here it goes, you guys. Oh, it worked, okay, good. This is exactly what we're looking for. And good news, it's running on our hardware accelerator. All right, perfect. That is so rare. I don't know if you guys seen, if you've been watching and following along, obviously, we usually get errors when we run. Yeah. It works, I know. First try, that time. First try, we read, this little bit of code here, and we're following along sort of with our tutorial. We're making it different. Obviously, look, these two, they don't look the same, do they? They don't look the same. We're following the tutorial. We're making them look a little different. Okay. So let's see what we got here. Let's see what we got. I want the argmax. All right, good. Yes, right there. So as you can see right here, this part right here, this is the middle one. This is the answers. This is where we did the argmax. So it says it's going to be number 8. It's going to be 0 and 7. What we could do is make sure that we should look at it too. We should look at it to see if it looks good. That's what we should do. Maybe what we could do is also do show images. Let's do show images. We try. Hey, Andre Rubert, thank you for subscribing. Welcome on in. Happy Thursday. We're building ourselves a CNN convolutional neural network. Hey, Sebastian. Hello. Hey, rival Sebastian. Good to see you. welcome on in. Let's get our let's see, show image. Maybe we could do a show image and see if it's correct. Do you think that would work? It should work, right? So let's try show image. Let's do it. Let's see if show image is gonna work. Okay, we'll do this. We'll do test and we'll do Lynette.show image. Okay, let's see how good the model is. I'm so excited. All right, this is like the moment of truth right here. This is the moment of truth. We're gonna find out. Will we get correct answers? So are we progress? We're gonna find out. All right, let's do a new poll. Let's do a new poll. All right. Obviously, what we're gonna say here is we're gonna ask you a question. We're gonna say, start a poll. We're gonna say, okay, what will the model get at least 3 correct answers? I think it's going to be a batch size of 64. So at least RNG states at 32. If it's 32, RNG states 32. Let's say, how about 75%? Let's do 75%. We'll say 70% correct answers. Yes or no? Let's see if we get at least 70%. Can you look at the link share on Discord? Yes, I will. I'll look at the link share. Okay. Mark Lemon, good to see you. Welcome on in. So, can you share the docs you are following? Yes, absolutely. Long time. Hey, Sana, good to see you. Welcome back. All right, yes, absolutely. I'll post this over here on Discord, on the link share channel. All right, yep, there's link share. All right, paste. There you go. This is the tutorial we're walking through right now. What we're doing, though, is we're sort of following the tutorial, but we're making it our own, because that's part of the learning process, is what we're doing. Definitely, yeah. Nice. General, sorry. All right, no worries. All right, what do we got here? Here's the link. Translate Kagi, then change language to LinkedIn Speak. Oh, yeah, I was seeing that earlier. That was funny. Right here. I use Arch, by the way, like you use Arch Linux, and then it translates it to, I'm thrilled to share that I've successfully optimized my workflow by leveraging a highly customizable rolling release environment. My commitment to a do-it-yourself philosophy and deep diving into system architecture has significantly enhanced my technical agility and problem-solving capabilities. Always strive for peak efficiency and full control over my tech stack. It translated it good. It did, right? I use Arch, by the way. And then it translated to LinkedIn Speak. Oh, that's great. I like that. That's funny. I don't know I don't know why you don't have a lot of subscribers, but you're one of the few devs who really help community learn. Oh, yeah, well, we're just getting started. We're going to make this happen. Oh, it's my favorite song. I like this one. This one's my favorite. Yeah, we're just getting started for the most part. I mean, we've been streaming for not even a year. Not even a year yet. So we got a ways to go. Most of the streamers have been doing it for, 7 to 10 years. Same. Yeah. So that's it. Gen Z language, Reddit Speak. Oh, there's also other options? There's a few other options? Okay. Let me copy this link and open it up. Okay. I'm going to double check. Okay. Is there a config? Is there a night mode or a dark mode? I'm looking at it right here. I just UI language. No. Dark mode. Is there like a dark mode? I like it when it goes into, let's see, general translation appearance. Here we go. Dark. There we go. Save. All right. Okay. Let's try it. It's a fun language. Which detect language? English. Translate to. Wait. Where's the LinkedIn? Reddit. Oh, there's Reddit Speak too. Okay. I'm learning Pytorch using tutorials. Did I spell that right? Is that spelled correctly? Yeah, okay. Translate. Let's see what it does. English. It's translating. Oh, wait. No. I wanted it the other way around. The other way. Oh, got it. Okay. Verify I'm a human. Okay. I'm learning Pytorch. Where? Oh, it's translating. Okay. So, I'm currently learning Pytorch using tutorials. I see you're a person of culture as well. Our learning machine, yep, learning machine learning, has been a godsend. Thank you for coming to my TED Talk. Yeah, it's just like it. The CAPTCHA. I like that. The Chinese, yeah. It's the second day in a row you appeared twice on my feed. Oh, I know, right? SQ letter, there's no escape. There's no escape. Let's try Reddit, or let's try LinkedIn. Let's try that LinkedIn. Here we go. Confirm. Okay. As always, starts with that. Yep. I'm thrilled to share that I'm diving deep into Pytorch. I've been leveraging industry standards tutorials to sharpen my machine learning skill set and stay ahead of the curve in artificial intelligence development. Continuous learning is key to driving innovation. Hashtag with the light bulb. Yep, gotta have the light bulb in there. Hashtag Pytorch. I followed you when, hey, I was going there. Canada. In KMG, I remember you. You followed me when you were doing some open captions, and you brought so many inspiring videos to your feed. Hey, that's great to hear. That's great feedback. I appreciate it. That makes me feel really good. In the fun language category, oh, the CAPTCHA. Oh, we got it. Is there another one? Let us know if there's another one. We'll try it. For now, though, let's get back to our tutorial. Okay. 0. Okay. Let's see. Oop, 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 oop. Go back. Okay. You translated SDH into DC. You have the right into that in your profile. You translated STH. Thank you for the hearts, you guys. Appreciate it. I see those floaty heart icons there. They're flown up there. Okay. So I think we got it mostly. Let's just see if we can do the image show here. Okay. This is what I want. Right here. Let's see if it gets it right. I believe the batch size is 64, right? No, it's 128. Okay. 100% yes. Are you guys crazy? Okay, we'll find out. CNN. Okay, here we go. Let's see if it gets it. You know what? Okay, here we go. All right. Did it get it right? All right, first one. Here we go. Are you guys ready? We're gonna strap in. Okay. So we're gonna have to take this. We're gonna take a look at this. All right. So the first one, it's a plane. That's definitely a plane. Did it get it right? Yep, plane. They're right here. Yep, plane. And that looks like a dog, or it kind of looks like a cow. To be honest, is that a cow? But I don't think we have a cow as an option. Let's double check. Is there a cow? I don't see one. It's just gonna be dog. So it's got to be a dog. That's a dog. All right. Next one. Deer. Yep, that's a deer. And the next one's a plane. We did a 100%. Check that out. We trained ourselves an AI model that got 100% accuracy. Look at that. From Kagi. All right, look at you. We did it, you guys. Hey, Miguel. Good to have you here. Thanks for subscribing. We did it. Nice. 4 out of 4. Yeah, there you go. 100%. Success, you guys. We did it. Something in for Discord, so translated something into LinkedIn. I sent the results into the Discord. I'll have to write that into your profile. Oh, I got it. Yeah, there you go. Torva, I get it. Yes, definitely add it to your profile. We did it, you guys, 100%. Okay, so let's go over all. So this is just 4 samples, right? That's just 4 samples, which I was, expecting that maybe one of them would be wrong. It got them all right. It did. It got them all right. So what we're going to do next, and we went above and beyond what the tutorial offered us, right? We're doing some extra things. We did a few extra things. We're using a slightly different optimizer approach. We're using a slightly different output design pattern that's better fit for what AI model should be, rather than just a solid number that is between 0 and 10. We're using 1 hot. AI models perform better on numbers between 0 and 1. That's what we did. And we found good results, as you can see. Okay. Since we did that, let us go over here, hide that, and we're going to go through every single one of these now. And we're going to check the answers. So let's see how we can check the answers. Okay. So labels. We got to do argmax on the labels. All right, so argmax on the labels as well. Let's do that as well. La la la. So labels are the correct answers, right? Labels are the correct answers. So we're just going to read this: correct answers, and then model answers. It's the AI model. Here we go. Okay. So we're gonna do a quick little comparison on that right there. Just a little quick smidgen comparison. But all right, let's see what we got. Okay. All right, let's see. Yeah, 100% again, right there. All right. We're doing good. All right. So now we did it twice in a row. That means that counts. That counts twice in a row, as you can see here. Correct answers versus the actual AI model answers. Boom. 8871. Oh, it makes me so happy. It's like validation. You love it, yeah. The music makes this live so chill. It's pretty good music. This is called YouTube Studio Creative Commons free music. Where are we located? We're currently on Patrick. Okay. Where's Patrick at? It's around here somewhere. Patrick. Yeah, right there. So we're about not even halfway yet. We're not even halfway through the playlist, which means we got plenty of time. Damn cool. Isn't it great? This is great. I love it. Okay. Success, you guys. Success. So what we need to do now is we need to compare all the answers with programming and test every single one. Now, there's probably going to be one or two that are not correct. If we get 100%, I'll be super surprised. If we get 100% out of every single sample. Right now, we just got really good, right? We just got lucky. We got lucky. Okay. So we've got our answers. We got our output. We got our labels. Let's do this. We're gonna rewrite this. So AI answers, and we're gonna say correct answers. We're just gonna rename these things so we can track it easier. And this will be argmax, like this. All right, we can delete those things because we got our debug information. Okay, so AI answers equals output and labels. Looks good. Now we need to compare these two arrays. So what we're gonna do is we're gonna do a simple, what you call a list comprehension for A. So it's gonna be A for A in correct answers. And we're gonna test this. A equals, A will be is A the index, wait, we gotta enumerate. Hey Jacob, thank you for saying hi. Welcome on in, good to see ya. Happy Thursday, it's already Thursday, you guys, it's crazy. Time goes by so fast. Okay, so I think we need to do enumerate on this, so that way we can compare. Oh wait, there's a better way to do this. Hold on. Let's find out. Let's do it the Pytorch way. Let's not do the Python way. Let's do the Pytorch way. This is why we're doing this. Import torch. We're gonna say A equals torch dot tensor 1, 2, 3, 4, like that. And then we're gonna do the same thing with a B array. All right. B. There we go. So A and B. So we're gonna say A equals B, and it should give us a new tensor. There we go. Instant comparison. See, this is why you want to use the framework, because it can do this, like that. Really easy, beautiful things. So this gives us a new array. So what we can do is, instead of doing, we don't need to do this. We just do, right? So we go, let me create a variable up here that will be accuracy. Accuracy equals a simple array, and we're going to say concat accuracy dot concat, which I do believe is, let me double check this. Yeah. Oh, hold on. Wait. Can we do that? Okay. C equals C dot concat. That's not okay. Wait. How do we do this? How do we append? Not append. It's dir C. I want to grab. It's in Python. How do you do this? Insert extend. It's called extend. Okay, it's called extend. Oh, hey Sandroot. Yeah, you figured it out, Sandroot. All right, thank you for paying attention. Yep, it's right there, right where our cursor is, right here. Extend, right there. Okay, so we'll use extend. So we say C dot extend, and we'll go 1, 1, like that. C. All right, let's try it. So let's try it again, and we'll go 2. Nice, perfect. Extend. Okay. Extend. we would go AI answers equals correct answers. Like that. Wait. Hold on. We got to do something different. This is going to be a tensor. So I believe we should be able to do detach num.cpu.numpy. Like that. I think. Actually sitting down and writing code is really rarity these days. Yeah, it is rare. It is. My brain is so cooked by Claude Code. I know, right, Rowan? I'm using Claude Code all day long. Codex, Cursor, Gemini, Brock, all the things. We're all day long. And it's so nice to be able to sit down with you guys here live on stream while we code together by hand to maintain our skills so they don't atrophy. When will we be able to, can you add the Pytorch tutorials repo so we know each file does? Oh, so we're only really working on one file. It's called the CNN file. Let me, right here. L. So it's this file right here. Loons, it's that file. It's called cnn.py. cnn.py. There you go. So that's not actually a link. Don't click that. Don't click that. It's not actually a link. NeoVim is IMBA. What is IMBA? I'm used to most internet acronyms. IMBA is the best. Alexander, I'm not used to IMBA. What is the acronym? IMBA acronym. It is imbalanced. Not even Google knows. A very good thing. Okay, got it. It's a very good thing. NeoVim is great. I like NeoVim. So NeoVim and Vim, standard Vim, which I use standard Vim, right? So you can see here I use standard Vim. I don't use NeoVim. I just use regular Vim. They're basically identical. And in fact, they pretty much are. The only difference is, the major difference, is that NeoVim, being a fork of regular Vim, added Lua scripting on top of Vim, which makes it easier because Vim script is not easy to deal with. It's not. Adam, okay, man. Late right now. Gotta go. All right. Check some homework. Sounds good. Hang out with you. Sounds good. All right. Love your work. Thank you. And your positivity. Stay the way you are. Oh, love you, Steven. All right. Bye, guys. All right. Adam, mister, thank you. Appreciate it. And enjoy the rest of your day. Thank you for stopping by. I see, Alexander. Nice. Okay. So I want to... Did we do this properly? Is this correct? Let us do this here. Where is that at? La la la. Oh, no. Here. Okay. Here we go. Okay. So I believe this will work. I'm pretty sure. Maybe. We'll find out. Let's do print accuracy. Here we go. Perfect. Okay. Let's see if that does the trick. Okay. So this will compare AI and real answers. We're testing the AI. This is where we're testing now. Answers. Okay, let's train it. Here we go. Let's see what we get. Is it going to crash? That's usually the answer. Yeah, I knew it. All right. Why is it? Why? Oh, the CPU. Okay. Expected all tensors to be on the same device, but found at least 2 devices. Yep. What line? 187. Oh. Which one is which? Okay, 187. Okay, so this one, which device is that on? We'll find out. What's my theme for Vim? It's called Groovebox. Vim RC. Right here, GRUV box. Right there, you guys. Groovebox. Right there. We got some Groovebox for you. It's called, I'll type in chat, GRUVBOX. I like it. Makes me happy. Okay, so which one is on the right device? So the output's here. That means this one's on that device, and this needs to go .to device, like that. I'm pretty sure. That should do the trick right there. Boom. Let's see if we fixed it, you guys. Let's see if we fixed it. I'm pretty confident now. Yeah, there we go. Perfect. Okay, so that is on MP. I want it to... I wonder if we could do this... I wonder if we could do it differently. Because... do we want to? Do we want to make this a... Do you think what we could do is not have to do this? Is there an extend in a tensor? Or is there a concat in a tensor? Let's keep this in Pytorch world. I know we don't need to do this level of optimization. We really don't. I know. You can say, hey, Steven, what are you doing over there? You don't need to do this optimization. I want to do it. This is what we're here for. This is why we stream live, to do this type of stuff. Okay. So this is going to be a torch.tensor. And we're going to say device equals device. I believe we can do that. This is going to keep it on the GPU accelerator. And it's not concat anymore. So Python, I think it's concat. Import torch torch.tensor. Let's do that. And then let's wait. Is it called concat? Where is that at? Concat. I don't see it. How do we do this? There's a way to do it. It's in here somewhere. It's gonna. There's so many methods. Oh my goodness. Oh, which one could it possibly be? Okay, we're gonna have to try something out. Okay, gotta go. See you tomorrow. All right, Loons. Sounds good. See you tomorrow, Moons. When are we going to, and what are we going to do tomorrow now that the model is working? We're going to move on to the next phase of the tutorial, which is going to be, it says introduction to tensors, but I don't know if we're really going to do that because we might have already done that. This might be too simple. We might do something else though. Well, there's a few things in here that are interesting. We might do some of this tomorrow. Okay, so it's just gonna be the next page with whatever this is. That's what we're gonna do tomorrow. Okay. Can you just take the sum of the trues, divide by length in the tensor? Yes. Rowan, that's exactly what that's exactly what we're going to do. You got it. The thing that we're optimizing for right now, which is completely unnecessary. I know you can tell me, Steven, this is unnecessary. What are you doing? You don't need to do this. I understand. We're going to keep all these operations on the GPU instead of merging them over to Python on the CPU and doing that stuff. Or laying the answer. Yes, exactly. You can do that. That's what we could do. We're trying to keep it on the GPU. All right, Loons. Thank you for stopping on by. Okay. So let's keep going, you guys. Oh, yeah, exactly. We're keeping it on the GPU. So I think we need to do something where we do concat on a tensor. How do we do that? Chat, how do we do that? How do we do concat on a tensor? Is it also extend? We're just gonna try. We're just gonna start typing things in and find out. Okay. Tensor. Nope. Thanks. Thank you. Yep. Okay. Perfect. There we go. Delete. Okay. A equals A dot extend. Not a thing. All right. What about A dot concat? Oh, not a thing. Concatenate. Nope. Not that either. Is it concat? It is. Is it concat? It's not happening. Is it torch.concat? Ah, there it is. It's in the torch. It's in the root of the library. Okay. So, try cat. Oh, okay. We'll try cat. Okay. We'll try cat. A.cat. Not caught. Cat. Nope, not that either. What about torch.cat? Cat also works. All right. So we've got two methods to try. So we're going to say cat. Actually, no, wait. Accuracy equals torch.cat. And then we will bring in... we don't need to do this stuff anymore. We don't need that. Get rid of that. Get rid of this. Okay. That will be the new array. And then we need to say accuracy. That way. Okay. I think that'll work. I think this will work. Let's try this. Keeping it on the GPU, guys. Keeping it on the GPU. See if we can get it to work. Okay. Don't worry about the warning. I want to get rid of the warning. Okay. We got a problem. Tuple of tensors. something out none. Received an invalid combination of arguments. Okay. What about concat? Concat. Cat might be different. We don't know if cat's the same. We know concat should be what we want. Okay, it's the same thing? Oh, they're the same thing. Okay. The person looks like one of those people that is anywhere between 29 and 70 years old. Oh, yeah. I see what you're talking about. Looks like yep, exactly. Androgynous. I know, yeah. Don't worry. The AI sees this. I put my face into AI and it makes the same mistakes. Don't worry. It makes the same mistakes all the time. It gives me new body parts. It's like, wait. No, I'm a man. I'm a human man. I'm a human man from Earth. Hey, Jacob. Welcome back. Good to have you here. All right, so we need to fix our concat. Received invalid combination of arguments. Got tensor, but expected tuple of tensors. We can fix that. There you go. Tuple. I tupleized it. Do you like that better now? It's a tuple. This looks really weird, doesn't it, you guys? Look at that right there. I bet you didn't know Python could do that. Actually, it might not be able to. Dim. Dimension. Oh, dim. Oh, we got to do a dim. Oh, look at that. Okay, is that right? Okay. I want to double check. Let's do print this. Okay. Let's print that. And then I want to print, I want to print these other things too. We're going to debug you guys. We got to make it look good. Got to make it look pretty. Like and subscribe. Oh, Jacob, thank you. Yeah, you guys like and subscribe if you, why did AI give you those horse-like veneers too? Oh, LMAO, just a better prompt. I know. I know what you're talking about. Yes, I have had orthodontics work. Let's see here. Correct answers. All right. Let's print everything now. Let's print it all out. Okay. All right, looking good. False. Is that not a good outcome? It's not what I wanted. Is this correct though? I want them all to be true, but that does. It looks correct to me. All right, let's try it again. Okay. All true. Rolling the dice. Oh, wait, one true. We got one true. Okay. Come on, you guys. Rolling the dice. Yeah, there we go. Oh, that's good enough. All right. 75%. Okay. So this is what I'm looking for. It's all in the tensor. And so what we can do is sum and get the length. Does the tensor have a length? All right, import torch. A equals torch. Torch dot tensor. 1, 2. A dot len. It's not. What about len? Wait, actually, no. It could be a dunder. So we should be able to do this. Yes, nice. Okay. So once this is all done, we should be able to get the full answer here. Okay. We'll say len, our accuracy. Not accelerator, accuracy. ACC. There we go. Divided by the sum of the accuracy. Now, can we do, is it a dot sum? It is, okay. So that should be 3? Okay, good. So that's length of the accuracy, and we say accuracy dot sum, like that. And then that is going to give us our final answer, 100% of GPU dot detach dot, or can we say just item? Item like that? I think we can just say dot item. Let's try that here. Yes, there we go. Easy mode. That's why we do frameworks, you guys. All right. Print f string like that. And then we're going to say accuracy. And then I want it to be a float. Can we do this? I believe we can do this. I think we can do it like this. All right. Colon dot 2f. Perfect. Okay. Well, I'm gonna try it here. Okay, here we go. Here we go. All right. Success or fail? Success or fail? Oh, nice. Okay, good, 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 good. All right, that number looks correct. All right, let's run it across 100% of the data. Let's do 100% of the data. Also, instead of doing this, I'm going to try a little something here. Turn your eyes away. Turn your eyes. You're not seeing anything. You don't know what you did. No, nothing to see here. Nah, you don't see anything. Train loader. You're not looking. Turn. La 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 la. Don't see anything. Not telling. Nothing happened. You didn't see that. Good, good, good. Okay, good, 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 good. Nice. Let me do a multiplication on that. 100%. 1.0. All right. All right. Right. Yeah. You didn't, nothing to see here, you guys. Nothing to see here. La la la. 100 times. Can we do that? Will that work? I'm pretty sure. I'm pretty sure it might. Yes, it does. Okay, good. And then we'll say percent to make it pretty. Just like that. Okay. Here we go. Moment of truth. See here, 75%. Good, 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 good. Okay. Okay. Now we're going to test it across all the data. We'll do all the data, 100% of it. So let's try it. Close it. Yeah, we gotta close all these things real quick. Okay. We could do per. We're not going to do per. We're gonna try this. Okay. How big is it going to be? This might take a really long time. This might take a really long time. So it'd be nice to have some sort of accuracy, or at least some sort of indication of how far it's gone. So I suppose we could just do this. Let's see, hold on, batches. How do we say this? I'm curious about this. How do we get the batch size? Oh, we just do iterations. Got it, okay. We'll just do iterations. We'll try this. Okay, perfect. Thank you for the hearts, you guys. Appreciate it. I see the floaty heart icon showing up right there. I see them. I see what you're doing. Okay. I want to... Where am I at? You distracted me with the floaty heart icons, you guys. You got distracted. Okay. Batch. Okay, we're doing batch. Okay. Batch equals 0. And we're going to increment this. We'll say batch plus equals 1 if batch mod 100. We'll say not. Then print. Okay, and then we'll finally print. Print final outcome. Here we go. Perfect. Okay, I think it's it. There we go. And then we just click the run button and we'll see how good it goes. Test loader looks good. Okay. Boom. Run. All right. Are we going to see success or failure? Oh. No. Stay. Go up. Go higher. 63. No. It's got to go. Oh, it went up a bit. Okay. It's kind of like it's central. Oh, okay. 63%. Well, it's better than 50-50. It's better than 50-50. I think we did pretty good. What happens if we try it on this? Yeah. Let's try it on the actual data that it learned on. Let's see what its retention was. Let's see how good it was at retaining the knowledge that we gave it. All right, this is a retention test. How good are you? It better be better than 60. Oh, good. Okay, a 70. So, okay, good. Okay. Hey, it's increasing. Keep on going up. See if we get 75. That would be so good if we hit 75. I don't know. It seems to be stuck at 72. I think we're going to get stuck at 72. Oh, uh-oh. Oh, it's popping up a bit. I don't know. Yeah, it might get stuck at 72. All right, that's actually pretty okay. So that's level of retention. Now, we did a very heavy regularization. Very heavy. So if we changed this and we improved how we were doing this, we might be able to increase the accuracy. I think we might be able to do a pretty good job at increasing the accuracy. However, not too bad for this tiny little model that we made right now. I think we did pretty good. All right, I think it's just going to stay there at 72%. How can we improve this? How can we make this even better? So right here is one of the lines that we could do. We can improve this. We might be able to increase this a smidge so that way it's got more memory. We might be able to reduce the inputs into a grayscale rather than color. Right? We could do that as well. That might improve it. We could... we could drop... We can do some fine-tuning. Do you guys want to do some fine-tuning? Yeah? You want to do some fine-tuning? All right, let's do some fine-tuning. So what we're going to do in order to do some fine-tuning is we're going to load the existing model that we have, and then we're going to update the weights with additional training. Let's do some fine-tuning, you guys. Let us fine the tunes. And we will fine-tune it with probably, I don't know, let's go like 5 epochs. And we'll reduce the batch size to 16. All right. So it's a significant reduction in regularization. And... oh, what's good? Hey, how's it going there, Edward? Edward, good to see you. Welcome on in. Happy Thursday. We are building a convolutional neural network, which we actually just finished training. We got 72% on the outcome. Now we're going to do some fine tuning. Has anyone in chat, has anyone ever done fine tuning before? Have you ever improved a model after it's already been trained? Well, that's what we're going to do right now. All right. So let's take a look at how we want to do that. So we're going to train it again. We're just going to run on train. Not yet. All right. Well, you're going to witness it right now. La 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 la. Fine tuning. Train. Okay. So instead of, we're going to load the state dictionary. Instead of that, we're going to also train it. We're going to train it again. Right here. This will be fine tuning. Let's see if we can make it better or worse than 72% recall. 72% recall. But we'll definitely try it. Nice. Sounds good. Okay. So that's all we had to do right there was just add this line right here for the fine tuning, because we're just going to go over it with different hyperparameters. So we trained it once, and then we're going to train it again using slightly adjusted hyperparameters. And let's see if we can make it better. Also, what's our optimizer? What is our optimizer? It is a Atom W. Okay. This is also something that we can modify. We could see if we can get better outcomes using SGD. We could do other things. Before we save it though, let's also save it here. So we're gonna, every single time we load the model, we're gonna refine tune it. So we're gonna change this up. So let's comment some stuff out here. Here we go. Period. And we're going to grab this and we're gonna, okay. The net.2, oh, no, we don't need to redo that because we already did that, I believe, right? Lynette's already on the device. It's already on the device, so we don't need to re-device it. So hide that. Get rid of that right there. Hey, how's it going there, Jinlu? Good to see ya. Welcome on in. Happy Thursday. I hope you're having a good day in virtual reality, maybe. What you working on? Okay. I think this will help us with our possible accuracy improvements. I think that's all we need. Okay. And then we're going to, we'll leave it the same. Okay. We're good. Okay. Run. Any errors, any problems? I don't foresee any problems. Okay. Oh, yeah, there. Oh, wait. Yes. Okay. It's already improving. We fine-tuned it. Oh, no, stay down, stay low. No. Don't. Down. Rowan. Is density your number of nodes? Yes, it's the number of parameters per layer that essentially units, right? I'm not super familiar with convolutional neural networks. I only really have worked with a flat network. Yes, and small attention models. Yeah. Okay. So my density is just it's the term that I grabbed when I learned TensorFlow many years ago. They like to call it density. How dense are the dense layers, the fully connected layers, right? The fully connected layers. There's also, you could also call these things like units slash, I know they're the parameters, right? Parameters. They are right here. So you can see what the dimensionality is, like the width by height. So this is 25 by 16 over the density, which is 256. Oh, good day. All right, good to hear it. You took software development test and almost aced it. If it hadn't been for writing a file in C++, oh, is writing a file a little bit tricky? Was there something that, I feel like if you get pretty close, it should count. There needs to be like variations of accuracy here, because if you're close enough, that means that you're gonna eventually get it once you compile it. So, I think that should count, don't you? I do. I think it should count. Okay, you guys, where are we at? Okay, did we fine tune it and did it get better? The cost went down ever so slightly. Let's pop up here real quick. Yeah, well, did it though? I mean, it's down by a couple of points. It's down by 2 basis points. So that counts as fine tuning right there, right? What else are you supposed to get from fine tuning? Right? What else can you get from it? All right, that should, okay, here's the last epoch. I think we should adjust it to only do 1 epoch. Let's have it adjusted to only do 1 epoch, because it seems like we get the majority of the benefit from fine tuning with just 1 epoch on the new updated parameters. So we could adjust the learning rate to bump that up just ever so slightly. After this, we'll try an adjusted learning rate. We'll see if it retrains and makes it better. Yeah, we're trying to use Delphi. Oh, Delphi, a way of writing files and documentation was more vague. All right, now it's doing the accuracy. Did it save the file? That's what I want to know. Did it save it? Can I quit out? Where is that at? Right around here. Okay. Right here. Okay, so it did. It saved it. Good. And now it's doing the test. Now it's testing it. Okay, great. Okay, right there. Testing. All right, cool. Maybe cost didn't go down much, but have the generalization better? Yeah, it is. Look at 75% right there. Have you seen fine tuning ever work like that? I bet you haven't. I'm just really happy about that is what I'm going to say. Look at that, 75%. We reached our goal, didn't we? We reached the goal. Just a little smidgen of fine tuning thing for the party poppers, you guys. We did it. Oh, that makes me so happy. I feel like we learned something, didn't we? Didn't we learn today? We doing pretty good? Yep, the cost didn't go down that much. However, the good news is the accuracy improved, which means the model is getting the correct answers more often. Are you still testing on training set? Oh, you've been paying attention, Rowan. That's the part like I was like, this is actually, let's see it test. Oh, you're right. Okay, it was on the training loader. All right, well, fine. Here, we'll that was the first. At least, okay, so it's got better recall, right? It's got better recall. Do you remember what it was before? So before, it was running on the test set, and it got like 60-something%. Let me go back. Let's see where we're at. Let's go back. So this is the recall. 72% was the original recall on the train set. Then it jumped up to 75, right? So we got 75% there. So we improved that. And now, so our new goal is 72. Okay, so we gotta do better than, no, not 72. 62, okay. 71. So we just gotta do better than 62%. So if we do better than 62%, if we better than 63%, right? Then we're good. Thank you for Rowan. You paid attention. I was like, don't look, nothing to see here. So the good news is, yes, we got better recall, which is great. Oh, and you're looking in how to write a bootloader because you were bored. Jin Lu, bootloader? What are you booting over there? What are you loading in the boots? Are you talking about like a kernel? Loading the boots? Okay, 75% on recall. So Now we set it to test load, right? The test data, right? So we're doing test data now. So we just need to do better than 63. Should we, here, I'm not gonna fine tune it. We already did some fine tuning. Let's try it again. All right, better than 63. Better than 63 is what we're looking for. Well, I mean, it didn't really make a difference, did it? Okay. Hey, how's it going there, Serendip? Good to see ya. 63, well, hold on. Final outcome. All right. We got 75 and 63. Okay, so it's basically the same. That's better than 63. All right, let's see if we can refine tune it. Let's do some more fine tuning, you guys. Let's do some more fine tuning. Let's try to get it up above 63, right? So right here is 63. Let's try to get it to 64. Let's try 64. Okay. Let's make our way. Save the model, fine tune. All right, fine tuning's re-enabled. We get our test training or test data there. Okay. Run. Boom. All right. Let's see where we get now. Let's see where we get. Oh, did we make it worse? Hold on. Cost. Oh wait, no, that's way better. That's way better cost. Oh no, isn't it? No, the cost was at 84. So we get the cost at 84 and now it's worse. Okay. Whoops. Should we let that finish? I think we shouldn't let that finish. I'm scared. Okay. Instead of saving the model, here's what we're gonna do. We're going to let it try. Let's see if we can make it better. Okay. The cost might be higher because our learning rate is higher. So let's see if that adjusted, if it's okay that our cost went up, our accuracy might be better. Only save the best one. Yeah, that's right. We could do that. I've done that before. So what I've done before is I set loose a whole bunch of models with a whole bunch of very random hyperparameters, and I parallelized it, and I ran like maybe 100 at a time. Maybe more like 10 at a time, right? Realistically. Hey, Jacob, good to see you. Jacob, thank you for saying hi. You've been here. Jacob. Cost is going up. Yeah. Oh, it dropped. Oh, we made the fine tuning made it worse. We made it go worse. Okay. No worries. We didn't save the model. Hey, John Deere, good to see you. Ooh, that dropped way bad. Okay, no worries. We didn't save it. See, I was worried. I was like, maybe we shouldn't save it. I think we might not want to save that. No, let's not save it. All right, let's go down to 8. Try 8. And let's do a lower learning rate. Let's just ever so slightly adjust it. Okay. I think we can save this one. I think this one's okay to save because we're doing very, very fine tuning. Uh-oh. I know, right? Uh-oh. Trying to do layer specific adaptive quantization. Oh, no, good news is no. We're doing is we're updating, we're not quantizing. We're physically going in and actively updating the weights. We're not truncating them, we're updating them. We're fine tuning. I think a few layers are becoming worse. Yep, that's what happened. You know it. All right, let's resave and then load. Okay. Hey man, love the stream. Oh, thank you, Anzi. I appreciate it. Good to have you here. You have a pocket knife. Oh, Jacob, what are you gonna do over there? Oh, hey, our cost went way down. Ooh, look at that. We got a much lower cost now. We did good on our cost there. Ooh, we're saving this one. Okay, we're not touching it. We're letting it go. Ooh, down to 0.5. Oh, look at that. I would be very happy if our accuracy increased to 64%. I think that would be amazing on our test data, which doesn't sound like it's very high. No, it's not that high. Oh, we did it way better. Oh, that's way better, you guys. All right, that's an improvement right there. That is a dramatic improvement. I'm like, I hope we get 64, and it jumped up multiple percentage. Look at that right there. Final outcome, 67%. Can you check the F1 score as well? Sure, let's do F1 score as well. Okay. All right, we can do that. 1 second. There is a built-in Pytorch F1 score. There is. And we've got all of our data here under accuracy. So we've got all of our accuracy data here. Do you like me, Jacob? Of course. I like you. You're fine. You're doing okay. What did we tweak? Oh, what did we tweak? Okay, so here, check this out. So we reduced the batch size, so we have lower regularization, and we reduced the learning rate. So that way we're doing smidgens, little smidgens of tuning there, right? The little teeny smidgens. Pytorch is a macro called macro F1 score, as far as you know. That is exactly what we are looking for. Thank you. All right, so it's called torch.f1 score. So Python import torch, torch.f1 score underscore score. How about this? Dir torch. Okay. Then we'll search for it. F1. I don't see it. I don't see it. All right, it might be in a utility or something. All right, clear. All right, so let's see. Pytorch, torch F1 score. Is there a method? I want the method. Will you make a video about keep Android open and inform people, the developer, as to also provide the link in the description? Just combat. Actually, that sounds like a... Wait, hold on a second. Wait. Binary F1. Yes, we want binary F1. There we go. Metric. Torch sigmoid logits. Okay, so we're going to have to do a few things here. Torch, I want the built-in F1 score. I don't want to write my own. There's got to be a built-in one. Nope, I think you need Pytorch metrics. Okay, got it. Got it. Matrix. The torch, a tensor? It's got to be a tensor. So, torch.tensor. Like that. Dir. All right. F1. No, I don't see it. Hey, Mr. K, good to see you. Welcome on in. All right, just combat 4. That is a really good idea. That is a really good idea. You got to keep Android open. We got to, because I have a 1 Plus. I have a 1 Plus, you guys. I love Android. I'm an Android person. All right, so is there a built-in method? Built-in. There's got to be, right? There's got to be a built-in method. Pytorch method for F1 score. I don't want to write one from scratch. Binary F1 core classification. Torch metrics. Oh, okay, got it. Yeah, I'm not familiar with torch metrics. This looks like an additional library that we currently do not have. All right, so let's double check. It's called torch metric. All right, so import torch metrics. Okay, so I got to install it by requirements. So this is called torch metrics. Okay. Pip install requirements. Grab our torch metrics there. Okay. Looking good. Okay. Binary F1 score. And then we've got our predictions and our targets. Okay. So what I could do is I need to think about this for a second, because the way we've built this up, we need to get all the answers and all the targets in their own arrays. So I got to think about that first. You posted a quick video of what you're doing in general. Oh, Jinlu, all right. I love your hair. Thank you. Appreciate it. I tried to make it look fancy for you. Jacob, appreciate it. That's very nice for you to say. I combed it and made it look pretty. I spend time on it. Every day I spend time on this to make it look good for you guys. I do. And Jacob, you're the first person to say thank you. I like it. It's so good. I appreciate it. All right. So torch metrics. Okay. So we got a binary F1 score, which is exactly what we want. We've got that data. We got our predictions. We got our targets. Now I just need to create a separate one. All right. So let me do this. Torch metrics classification. Okay. Let's do this here. 0. All right. From torch metrics. Let me do this right. Metrics.classification. Import binary F1 score. Right? Like that. Binary F1 score. Good. Okay. Great. Excellent. Okay. Now we got to do a couple of things here. We need our targets equals a torch tensor like this, and we're going to have our labels. Although we've already made a name labels. Predictions. Okay. Predictions. Oh wait, we don't need that. We have that here. Okay, we've got our output right here. So that's already done. So we just need to. Actually, wait. I'm wrong about that. I'm wrong about that. 1 second. Predictions equals. Because we need it concatenated. Okay. So let's do this. We need to capture data for F1 score. We will say targets torch.concat targets equals like this. Okay. In a tuple, it's got to be a tuple. They like them tuples. Targets, and it's going to be outputs. Okay. Output like that. I'm pretty sure. And that's going to give us, although this is not the binary though. It's not the binary. We might need to do something different. And love your mic too. Oh yeah, it's a pretty good mic. Thank you, Jacob. Appreciate it. Yeah, this is a Shure mic. I got the Shure mic. It's what all the streamers have. Okay, so this is the part I'm not sure about. So I know this will work. I just am not sure about how I want to deal with it. Predictions equals predictions, and we're going to call this the answers, right? Or correct answers. Correct answers. Yes, correct answers. I think. Yes. Yes. I think so. Missing a parentheses. Oh, are we? Where's that at? Seems good to me. And then let's do a binary score. All right, so I'm not going to do any fine tuning this time because we improved our day. I'm late. What did I miss? Hey, Anasazi, good to see you. We successfully trained and tested our CNN. We did it. We're learning Pytorch, you guys. We're becoming experts. Thank you for the hearts. I like the floaty heart icon. Good to see you. Good to have you here. We need to turn off the training for fine tuning and the saving because we're not going to do that anymore. And then we're just going to do the test phase here. Just the test phase. You're the CTO of a multi-million-dollar tech company and you're hanging out on YouTube Live? I know, right? Truly man of the people. That's what we're doing right now. I know. Don't worry. There's been some controversy on the matter. And it has been brought up a few times. We're making our way though. The plan is we want to become Pytorch experts. And I figured, hey, if I'm gonna study Pytorch and my jacket too, well yeah, it's got my company on it right there. You can see my company right here. Got my company on it. Okay, have you ever compiled a compiler before? Nah, don't think so. Have I? No, I've not. I've not compiled a compiler. I mean, I've made my own compiler, right? Everyone's done that. So technically, yes. Oh, check general. Sorry about that. I missed. 1 second. Let me save where I'm at right here real quick. So this is we're in a tough spot here. So we're gonna do a binary. We need to do this binary. Binary F1 score. We need to do this. Okay. To do right here. Okay. General real quick. Okay, here we go. Ooh, I like your backlit keyboard. Are you compiling a compiler? Is that what's going on? Why is it so pretty? Were you talking? I didn't hear. Okay, you're just making sound effects. You're doing what I do.
The compiler. Give me a second here.
Okay. Compiling a compiler. Nice. Jin Lu. Did it learn what a horse is? Yeah. Yes, it did. It did. We made it learn. And we did some fine tuning as well. And it worked better. We made it work better. It got a higher score. It was so neat. We did fine tuning, you guys, live on stream. It was great. Now we're going to do the binary F1 score. Do you play Minecraft? Scary mod. I've only played regular Minecraft and a few mods. I've done a few mods. Are you guys hiring? Yes. I'm a graduating college, and I want the... Okay, data science. Yeah, data science. That's one of my favorite things. I like data science. We've got big data at my company. You're looking for jobs? All right, in the Bay Area? Yep. Okay, so we're a remote company. Here you go. So we've got senior AI engineer, senior backend engineer. There you go. IT engineer and a solutions architect. So we got four engineering roles. Got 4 engineering roles for you guys. Right there. I'll put this on a link share. So that way you got it under link share. All right. Let's do fire emoji. Fire. All right. Go back to link. Perfect. Okay. Ooh, yeah. All right. Okay. So we're going to do binary F1 score. And then we are going to say, we did a good job and we're very happy is what we're going to do. Hey, Mushroom. How's it going there, Mushroom? RX necessarily about religion exists necessarily, possibly doesn't exist, therefore. So I like here's, all right, Mushroom, are you ready for something? Are you ready for your mind to get blown? All right. Some people say that science is a way to prove God. I kind of like that one. Science is the study of science and a way to prove. Doesn't senior need to be more than a few years of experience? Hey, I know, that's all it is. Don't worry, if you're capable, then we're here for you. It says senior. Does it really matter though if you have the skills? Does it? Yeah, and the wallpaper on your laptop is randomly picked. It's a good wallpaper. I saw it. It was like the sun in a mountain. There's a mountain and a sun. I saw that, Jinlu. I saw that detail. I was appreciating it. It was like a sun in the background and a mountain. Like a red sun. Very nice. What are the requirements for each of the roles? Let's find out. All right, you guys ready? All right, we're gonna look at some things about requirements here. Here we go. Let's see where that at here. Okay. You work on AI moderation, low latency inference. SDKs, observability, experience, large language models, high throughput systems, TypeScript, Python, or Rust, and you're comfortable with using AI to write the code for you. Isn't that everyone? It's good to have you here. What AI engineer suffice? Yes. If you can do it, if you can make it happen, there's some things you got to know though. Modern consistency points to quantum field and be fundamental, not an entity with a mind. Oh, is it, Mushroom? Okay. Well, aren't we all just the universe observing ourselves? You posted it without the terminal in the way real quick. Oh, nice. See, it was, I saw that. It was like a red sun with a mountain in front of it. It looks good. It's actually a really nice, randomly selected image. It's beautiful. It's pleasant. Jinlu, very nice. All right, you guys, we're gonna do binary F1 score. Are you ready? Are you ready for binary F1 score? We're gonna see if we can make it work. I've not used it before. Let's actually mess around with it. Let's mess around with it here. All right, thank you for the party poppers in the hearts, you guys. Python, Python. All right, import torch. So you go A equals torch.tensor, and we'll say 0, 1, 0, 1, something like that. We'll do the same with B, and then we're gonna say from torch metrics dot classification. Is it classifications? Import binary F1 score. What? Oh wait, no module. Okay. Classification. How about that? Ah, there we go. All right, we just got it off by one letter. All right. One of favorably randomly selected wallpapers for sure. Normally it's a gamble. Got some good stuff today. Definitely applying. Not all good, not in the years, but you're motivated to learn quickly. Nice, Rowan. Sounds good. Are you going to be live every day? Every day, every Monday through Friday. And next week, you guys, I'm going to have very early streams because I've got some crazy meetings happening throughout the day. So I'm going to wake up super early and we're going to do really early streams. Like right now, we're really late. So we're talking about like six hours or earlier. So it's going to be a big difference. Your laptop's also toasty right now. Yeah, if you're compiling, it would be. Have you ever tried Pygame? Absolutely. We sure have, Sputnik. We've done some Pygame on this channel. We've done some binary on this channel. All right, so binary F1 score A comma B. Can we do that? It doesn't like that. Threshold be a float. Oh, wait, really? It's binary though. Expected argument threshold to be a float in the range of, but got a tensor. How are we supposed to use this? Is how do we use this? Okay, so expected argument threshold to be a float. Okay, well, what if we did? All right, so B. Okay, how do we do this? In the range of 0 to 1. It is in the range of 0 to 1. I'm sorry, but it sure is. 0, 1. Do we have to do dot item? A tensor with 4 elements cannot be converted to a scalar. Yeah, it can. It absolutely can. Raylib. Oh yeah, Raylib will be fun to play around with on stream. Plus, it'd be a good exercise to do more C or C++. Hey, there you go. Have to go. All right, Jacob. Good to have you here. Thank you for stopping on by. Enjoyed all your compliments. Thank you. I don't know how to use this function. All right. It says right here, F1 predicts and targets. That's what we're doing. We are exactly doing that. Precisely. Not a little bit, but all the way. All right, A, comma. Well, here, let's do floats. We'll do floats. It might want floats. B. All right, binary score. A, comma, B. Okay. It's the same thing. We're doing what the documentation. We're doing what the documentation says. Well, it's not really a docs though, is it? We could also do scikit-learn, which I've done this. I've used this F1 score before. It's a little bit easier to deal with. Let's do. All right, let's do a.item. Try that. Okay, we can't do that because it's not. Okay, so how about detach? Dot CPU. Same thing. What about numpy? Like that. Okay. Binary F1 score. It's the same thing. Comma B. There we go. The truth value of the array with more than one element is ambiguous. Use a.any or a.all? What do you mean? Ignore the phone ringing, you guys. Should it be between 0 and 1? That is. It is, right? Look, right here. Right there. It's between 0 and 1. Right there. So, how does this work? If the F1 score... Okay, got it. Okay, so what we need to do is we need to grab... So I've got it in one hot. So it's looking for the what is it looking for? It's looking for the actual output. So it's looking for the actual output. So what I've done is argmax, right? I've done argmax, and the output is still going to be interesting. Okay. But I need to be able to make this work though. Here. We might switch to scikit-learn is what we might do. We might switch to scikit-learn. All right. Show sklearn example. I think that might be easier. Yeah, see right there. See, this is what we're doing. We got our answers. Oh, the targets. Interesting. Okay. That's why. Oh, got it. Looks good to me, but yes, scikit-learn is the best. Okay, good. Yes, you're right. Nice, thank you. Feels good to be right, you guys. Targets, CPU, numpy, F1 score. So I've already got scikit-learn installed. So let's try this. Import, from sklearn. I'm pretty sure I've got it already installed. .metrics. And then import F1 score. Import F1 score. All right, good. F1 score. Right there, like that. Okay. And then we've got our A and B. Probabilities. Do we need the logits? All right. So this is going to be our answer output. And okay, so A, B. We're just going to try that right there. Thank you for the party popper. All right, so we should say F1 score. Let's see, O-R-E, A, comma, B. Can we do that? Just like that? Oh, look at that. Okay. So this is going to convert it into a true or false. Got it. Okay. True or false? Okay. Do we have to do detach? Dot numpy. N-U-M-P-Y. Okay. Dot numpy. We might have to do something. Okay, see, now that's what I'm looking for. Exactly that. Can we do it with the torch, or does it have to be numpy? Oh, it works with that. It works with Pytorch straight up. Okay. So this is way better. We're going to do this approach. Okay. So we got that part working, and it just needs to have the numbers. Okay, perfect. Okay. Are you guys ready? We're going to do an F1 score. We're going to do F1 score. We're good to go. Okay, so that's our F1 score. This is going to be, we got our targets, and we're going to try it right here. Okay. What hardware setup do you recommend for running a convolutional neural network, especially for GPU and RAM? Well, you need to have enough GPU. The good news is your GPU, you don't need that much RAM, because what you could do is you could just have smaller batches. You could have smaller batch sizes, which means when you're submitting work to the GPU, it's really not so much about how much data set size you have. It's really about the size of your model. So you can have a pretty big model, big enough, bigger than you need it to be. And even your laptop will work. It will. Even your laptop will be perfectly fine. All right, you guys, this is the last thing we got to do here. The last thing we got to do is get our F1 score going. I think we should just be able to say F1 score here. Targets. Was it? Wait. Hold on. Target. Target first. Yeah, target first. Okay. I don't know if it matters. It shouldn't matter. Targets, comma, predictions. Like this. Okay, perfect. Let me say score equals. Okay, and we'll go print F our score. Score. SCORE equals. Like that. All right, good to go. What are we doing? Hey, how's it going there? Trentess91, good to see ya. We are building a convolutional neural network. We're running through all the Pytorch tutorials, and we are rebuilding, from most part, the tutorial in our own way. So it makes it a little bit better, a little bit easier, and a little bit more fun. A little bit more fun in our own way. Nice. So currently, we're getting the F1 score, which is kind of an accuracy score. It's very, very close to accuracy. That's what we're doing right now. And so accuracy is going to give you perfection. It's going to give you the exact number. How many got right and how many got wrong over a percentage, right? So you can, right here, you can see. This is our math. Where's that at? Right here. Oh, wrong window. Okay. So here's our math. Let me reopen that. Our math is right here. So you see that we're going to sum all of our items, and then we're going to divide it by the count. So essentially, it's going to give us the ability to say how many are correct and how many are not correct, and then give us a percentage across that. Interesting, yeah. And then we're going to do the F1 score, and you're going to see that they're very much the same. They're going to look exactly the same. Have you tried Claude Code as you have used Codex? Yes, I do have Claude Code. I use a very special version of Claude Code. My version of Claude Code hits Bedrock on AWS. I don't go through the main Claude Code. We go through a dedicated private Claude Code. Unlimited. And we give all our employees access to it. All right, F1 score, you guys. F1 score, here we go. Let's see if this works. And we're going to say print, and return. All right, let me double check. I don't want to. Perfect. We're not fine tuning anymore. Okay. Okay, Python, cnn.py. There we go. You can fit so much into Claude Code. You can fit so much Claude Code in. This is bad. Oh, it's so good. Hey, the Wahab, good to see you. Welcome on in. Happy Thursday. Appreciate your reply, Stephen. You're welcome. You're welcome. All right, self.numpy. Where's this? Why is that a problem? Can't convert NPS device into type num. Oh, yeah, okay, that's fine. We can deal with that. We can deal with that. No problem. Where's our problem at? Where is it at? Well, obviously it's going to be right here, isn't it? Here. Let's just do that real quick. Let's validate. Let's do the easy. Let's do the easy. How does your Claude Code hold up against the GPT's codex on VS Code, the 5.4? They're both very close to amazing. They're both very close to amazing. That's all you got to say. Anasazi, how does your... That's how it works. That's how it works. It's pretty good. Did you send another quick thing in general? Okay. What do you got? Ooh. Another background. And... Oh, neat! You got a nice little flip switch on there for your backgrounds. When you get tired of one, you can just bring up another one. I like it. So you're not paying Anthropic API tokens? Yeah, we're paying AWS for API tokens. Just paying compute minutes. Exactly. On AWS. Yep, you know it. Exactly, Rowan. Yeah, it's really cool. Nice. Jinlu, that was I'd never seen that before. You showed me something new today. Okay, so let's try the F1 score again. We're going to say .detach .cpu.numpy. Like that. There we go. We're going to do all those like that. Or, wait. We might be able to simplify this. We might not have to do this part. Let's try that. Okay. Let's try this. Okay. Let's try it now. AWS is cheaper than the main Claude API. I think they're basically the same price. The only difference is that we get dedicated throughput. Classification measures can't handle a mix of continuous multi-output and multi-class targets. Is it because it's a batch? Oh, we can only do it... Okay. So, we might have to say 0. Like this. How about that? Fair enough. On a large scale, probably since it allows better personalization. Does it? I think so. Our input should have at least one dimension. Satisfy. It does. Okay. Hold the phone. Print targets and predictions. Okay. All right, let's see what we got. Let's see what we're working with here. What are we working with here? Oh, got it. Okay, so we didn't. So maybe we do need to do the argmaxes. Okay, one second. We need to do these guys up here. We need to do these guys. Okay. We'll do AI answers and correct answers instead. All right, we'll try this. Okay, AI answers and correct answers. Oh, your terminal is not moving a single bit. Oh, it's just uninstalled. So you know you're doing stuff. If your terminal's not moving, you're doing stuff. How would you tell it to a layman what you're doing? Oh, we're teaching the computer to learn how to recognize images and pictures. That's what we're doing. We're saying, hey, computer, here's a bunch of images. Here's a bunch of pretty images. I want you to learn these images. I want you to memorize them. I want you to figure out what makes a picture a dog, what makes a picture a cat. And then I'm going to show you some new pictures that you've never seen before, and you're going to try to correctly guess them. That's what we're doing. We're training artificial intelligence. Or you're modifying the LLM itself. See, that's one of the things that these days, everyone thinks that when you say AI, it means LLM. And I don't mean that in a bad way. I don't. This is not a large language model. This is like traditional AI. Traditional AI. Deep learning. Not large language model. This is a convolutional neural network. This is a CNN. We're doing CNN, you guys. And we're doing F1 score right now. We're doing our best. We're doing our best on the F1 score. All right, so AI answers. And then we are going to grab that here because we need to do the same thing with the correct answers. Okay. And then I believe we do need to do detach CPU. Okay, there we go. Perfect. Your language model doesn't need to be large and to be impressive. That's a good point. It could just be a language model. All right. Where are we at? Another error and more problems. F1 score. Let's go. F1 score. All right. Target is multi-class, but average binary. Please choose another average setting. One of none. Macro weighted. I'm not sure. Oh. Well. We might have to solve this later. That'll be the plan for later, I think. I see what's wrong. I see what it's asking for. It wants these numbers in a 0 or 1, which we can give it. However, it's going to be difficult to compare. The numbers directly, because these numbers look perfectly fine to me. Like if you're looking at those numbers right there, I feel like they're perfectly fine to compare. Like no problem. Like none whatsoever. I suppose what we could do is divide by 10. Right? Can we do that? Divide by 10? We could try that. See if that works. All right. I'm not sure if it will. Let's see here. You can catch it a bit. Normally you would think so. Big when you're dumbfounded like me. Hey, I'd say it's pretty average language model. Hey, yeah, exactly. Pretty average language model. It's an ordinary language model. Continuous is not supported. What do you mean continuous is not supported? It's right there. Okay. All right, you guys. So much appreciated. I'm so happy to have you here. Okay. Well, you know what we're going to do is we'll be back tomorrow, and we're going to finish the F1 score. Tomorrow's Friday. We'll be back tomorrow. And then we are going to successfully move on to the next phase of the tutorial. So what are we doing? Oh, user, how's it going, user? We successfully built and trained a CNN. We are learning Pytorch, and we fine-tuned the model, and it got better. I think that was really great. I really would love to get this F1 score going. I really would. I'd really love to get this F1 score going. It's just not F1 scoring. It's what it's doing. Try that. Hide this. Okay. All right, let's see. So F1 score is basically an accuracy score. I really want to show you that the accuracy score matches. So that should work. It's between 0 and 1. It should work perfectly fine. What's the math part? The math part is where you're at. Yes, exactly. We're doing the math part. Which is 100% of AI is the math part. It's all the math part. All of it's the math part. So yes. Yes, exactly. All right. I thought that would be perfectly fine. Just like that. Nice. Yeah. Exactly. Oh, Paranormal City, thank you for subscribing. So glad you're here. Appreciate it. I really want to get the F1 score working. That's like the one thing. I want the F1 score to work. And we had it working. Like up here. And where's it at? We had it working. It's around there somewhere. It's not doing what we want it to do. It's just not doing. It should work, right? I guess we do get into binary. It could be 1 or 0 or 0 or 1. Interesting. interesting. I'm not sure. Oh well. Is not supported. Oh wait. It's just the error is just so massive. The error is so massive, and it's right here. La 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 la. Score return F1 score right here. Does it need to be a Boolean? Precision recall. It doesn't say that. All right. Though dot int. Okay, so it's got to be an integer. The targets have to be integer. Interesting. All right, logits predicts, and then you've got your preds and targets. Okay. So so it's this is binary. Oh, we've got a multivariate class. So we're trying to do something that we might not be able to do. We're trying to do something that we can't do, you guys. Hold on. Can F1 score work for multi-class? I like your eyes moving when you think. Oh yeah. Thank you, appreciate it. Oh, so it does work with multi-class. We just got to do something different. Oh, macro, average. We got to do something. We got to add some extra stuff here, you guys. Oh, that's right there. Okay. All right. We're gonna do it. That's the plan. We're not going anywhere yet. Ravel, Sebastian. Yeah, I know. When we're thinking, eyeballs move around. All right, we'll do macro. Okay. So we've got our numbers and our classes. Looks good. Target spreads. Perfect. Okay. So we got our argmaxes. So we got answers and predictions. Let me figure this out. Like that. Now we're talking. Yes. We're in the right spot now. Oh, we're gonna get it going now. Okay, so comma. What was it called? Average. It's going to be we'll just do weighted. Average equals W-E-I-G-H-T-E-D. Weighted average. Average equals W-E-I-G-H-T-E-D. W-E-I-G-H-T-E-D. Perfect. Okay. All right, you guys. There we go. I think that'll do the trick. Wait. All right. Is it gonna work? All right. So no more errors. No errors, you guys. Failure occurs when building the compiler. Uh-oh. I'm not gonna continue. Yeah, I know. Those compilers, they take a long time. All right, F1 score. Let's do this, you guys. You better work, F1 score. I'm working on to make you work here. Here we go. F1 score. Work. Don't crash. Hey, we did it. F1 score. Oh, look at that. Yes. It's about 50%. Okay. There you go. F1 score. Right there. Let's do it again so it looks higher. The F1 score is 41%. Not very good. Let's make it, let's end it on a high. Oh, that's 50%. Okay. Not quite much of a difference, essentially. Let's go. We did it. Serendip F1 score. We got it. Okay. Nice. It's fixed. Exactly. I want to see 100%. Let's see if we can get one that shows 100. Let's see 100. Run for 185. All right. Getting close. We should only have to do this 16 times. On average, 16 times. And there it is. 100 right there. All right. Hey, we did it, you guys. Thank you so much for joining. It was a lot of fun today. We enjoyed building our convolutional neural network. We tested it, we fine-tuned it, and we did the F1 score. As you can see, success right there. It looks good. So what we're going to do tomorrow is we're going to add in, yes, we did it, Sputnik Beans. Tomorrow we'll update how we did the training and the testing, so that way it does all of the data on the F1 score and all the data on the accuracy. Well done, Steven. We did it, you guys. Seek the vault. Thank you. Fear the ghost. Thank you for the party poppers. Fear the ghost. All right, we did it. All right, I'm so happy. We succeeded. Okay. Yes, Ravel. Exactly. Rivel Sebastian. Sebastian. Yes, we did it, Sebastian. We did it. Okay, you guys. So the plan for tomorrow is we'll keep on going with the tutorial. And let's go. We did it, Jinlu. We did it. We'll go further into the tutorial. Wrong emoji. Yeah, no worries. All right, you guys. Thank you so much for joining. We're headed out now. You did it. We did it. Sputnik Beans, we did it. Back tomorrow, you guys. Thank you so much for joining. See ya. Well done. Appreciate it. Bye, everybody. See you tomorrow. More Pytorch tomorrow.